Lists in lists. So we have covered lists and iteration, we have covered list slicing. Now for the true power, lists in lists. Which is as simple as it sounds. You just open a list with a bracket, then open another one, fill in some details, and close it. Comma, open another one, and so on. Great, thanks for coming. No, wait, that is not the important part. Slicing list in list is the important part. So if you do my list, open, 0, close, you can see the first list returned. To get the first item in the sublist, you do my list, open, 0, 0, close. Each of those numbers can be a slice operator. So if you want all of the first items, I replace the first 0 with 0:len of the list, which you don't need to do because those are the default values, and hence you just do colon, which gives you a list of 1 and 4. Why is this so great, you ask? Let's try a practical example. You have a title screen, and on that title screen you wish to plot some text strings at a specific x and y with a color. For optimal code, you want this to be a structure of arrays, i.e. you want .byte all x, .byte all y, .byte all color, .byte text load, .byte text high. Just for all of them in a row. But this is a pain to make, hard to read and update. So let's make a list of these details like so. It's enough to make the point. Now let's extract the data. So the x's, I want all of the first elements in the list, so title screen data source, open, colon, 0, close. And then the y's is just 1. Color is just 2. Let's take a look at how this looks in the listing before we get to the text. So we have transposed the data effectively. And we have our ducks in a row. Now back to the more complicated text. But the strings, well, getting them is easy enough, but that is not what we need. We want to instance them and then make a pointer to them, right? Well, I'm going to put the pointers into a label called tx text pointers. So let's just pull the low and high out of those. Now let's make that data. For this we need a variable, not a label. The difference is variables can be modified once you construct them. Labels can't be assigned to one set. Variables can change as many times as you want. To create a variable, you use the := operator, and I've assigned it to a list with just 0 in it, as the first string starts at 0 relatively. Now I make a start label that holds the text data, title screen text. We will use this later to offset the string pointers to their actual address. Rather than auto iteration, we are going to do manual iteration with a for loop. I'm going to use the for_in form, which will loop through each entry in the list returned by the :3 slice. For each string, I have two goals. I want to keep a track of the end of the string, as that forms the start of the next string, and I want to instance the string. So, .text text to place the string. Now I want to add to the TS text pointers list the current end plus the length of this string. To append to a list, you must use the concatenation operator, which is 2 dots. So, ts text pointers : equals. Again, we use colon because we are dealing with a variable. ts text pointers ... open list. We are joining a list with a list, so we must make a list, even though it only has one item in it. We want to get the last entry of it. Remember that negative indexes count from the end, so we index it with -1, and then we want to add the length of the current string. So len string, close the list. Now we must put this before the title screen data in the file, as ts text pointers must hold something before we try to place it into memory. I've done it after for explanation order, but in the file it must be before. You will see as this listing scrolls. Now you see the text up top, and you see the ts text pointers grow each loop, and it appends the offset to the next string. 1. There is nothing to signal the end of the string. 2. The string pointer started at 0. And 3. We are storing one too many text pointers. Let's fix the first issue. We firstly add a comma $FF after the text, like so. And we must add 1 to the length to compensate, as the pointer is now the next one. So an extra +1. For the second issue, rather than set the first one to be 0, we just set it to be title screen text. It doesn't matter that the label is after the list in this case because it's a fixed label, so TAS will do an extra pass to work out what it is and then substitute it. So variables must be used after they have been filled in with data, as you could modify it again and again and again down the file. So which modified value did you want? Fix can be referenced in any order, as once the value is known, it remains the same for all future passes. The one too many. Well, you should have already worked this one out. We just slice it off with one last caveat. Len text is not right. It mostly works, but if you have a string such as CBM with 1 high, then the len will tell you it's 9 characters wrong, because it is. But CBM and 1 is a single byte when the string is converted, so the computer will see it as a string that is 3 bytes long. To fix this, we cast this string to bytes before we get the length. So len open bracket byte open bracket text close close. We'll cover all cases. Wouldn't it be nice if the X and Y wasn't an X and Y but just the screen pointer already? Well, that is for next time. Join me then.